On time. And you're here, so you made it. Welcome to the Wisconsin Maritime Museum. My name is Kevin Cullen, Executive Director here since July of last year. But I've been with the museum 3 years, so many of you probably have or haven't met me. If you haven't, I'd love to meet you. So I'll be around afterwards and sticking around. But, you know, really this program wouldn't be here without our wonderful staff who organizes these programs, certainly our donors. In this case, actually, the sponsorship of this series, the Think and Drink, is the Green Bay Packers Foundation. So that was really generous to be able to do these for free this year. This whole theme of the year, if you haven't already caught on, is about frozen water, ice things. So yeah, tonight is apropos, as you can see on the screen. Just other housekeeping things. Save your questions, I guess, probably for the end if you can. I know there's going to be a lot probably, but we'll just try to keep the flow with our presenters going. But if it really is a burning question, I'm sure you'll be fine to answer them on the fly, but I'll leave it up to you guys. Other things, of course, cell phones, if you have them, if they're not already on silent, it's always helpful to not interfere with the flow of the evening. And restrooms are out the door. The bar will be open. The Polar Ice drink, the margarita, if you haven't had one, it's quite, I think I've heard is good, will be out there at least for at least another hour or so. Just other things related to the museum, just so you know, there's a lot of people asking about the submarine out here and when it's going up to dry dock. Well, that's a big thing that we're doing this year in September. So stay tuned, more on that. But the Cobia Dry Dock project, it's a major lift. It's been almost 30 years since it got brought up to Sturgeon Bay to get its underhull completely sandblasted off of all the quagga and zebra mussels. So it's a big deal. So if you're interested in it, there's information at the front desk, Cobia Dry Dock project. So exhibit-wise, there's a lot of new exhibits too. So come back if you haven't been already. If you're a member, raise your hands. Thank you, members, for being here. Great benefits. Of course, we have even member Mondays where we also do with the staff a deep dive into a specific topic. You also get these really cool magazines that we publish twice a year. These are well-curated content, but about the museum, called The Anchor. They're working on the next one, will come out in summer. Many benefits to becoming a member, and of course, it just gets you closer to the content that we're producing here and hopefully sharing widely, like we are tonight, with our wonderful guests that have driven up from Madison. So I want to welcome you to Polar Badgers Observing the Meteorology and Climate of Antarctica. So just as a quick lead-in, after the heroic age of Antarctic exploration ended in the early 1900s, an international agreement was made to reserve the Antarctic continent for scientific research. In the late 1970s, atmospheric scientists developed the Automatic Weather Station, AWS, that could survive Antarctic's harsh winters. The AWS program was transferred to UW-Madison in 1980. And since then, badgers have been observing and been able to characterize some of the world's most extreme weather events. So with us tonight, Dr. Matthew Lazzara is here from Madison, and Two Rivers' own, very own, in fact, born in Manitowoc, it turns out, and lives in Madison now, is Lee Welhouse. And they'll explain tonight what it's like to live and work in Antarctica and how studying the world's coldest climate can help us better understand the past, present, and future of our climate and planet Earth. So with that, please welcome Dr. Matthew Lazzara and Lee Welhouse.
All right, thank you all very much. Glad you could all come along this evening. I'm thrilled to be here. Lee just got back from Antarctica, so we're ecstatic he could join us for this as well. Yeah, it's really quite good.
13th trip.
Yeah, he's got two on me at this point. So yes, we're going to talk about observing the weather and climate in Antarctica. Lee and I have an interesting life in Madison. I'm a senior scientist at the University of Wisconsin. Lee works in my research team there. I'm faculty at Madison Area Technical College. Lee is my adjunct faculty there.
Yep.
So we were teaching lab this afternoon and then came right on up afterwards. So in fact, there's students were working on what we're going to talk about today, playing around with some weather stations. That's what we were having fun with today. So it's important for us to tell you everything you're going to see tonight, we don't do alone. There's no way. It's a team effort. This group here is what makes this work. So we have undergraduate students at both the technical college and the university. We've got graduate students at the university. We've got faculty at the college, staff at the university. collaborators that really make this project work. So we'll go through a little bit about us and the team and the science work we do, what it's like to be on the ice, and we'll go from there. I mean, yes, definitely time for questions and answers. We look forward to addressing all that you've got. So let's introduce ourselves. This is my beginning in meteorology. Started nice and early. Yes, a weather balloon found in my backyard, and I've never looked back. So I have my undergraduate degree from out east in Vermont. I grew up in Massachusetts, but my professors were from here. They were from Wisconsin. And when I started looking for like work, I ended up coming to the university. I had a job. I started out as the youngest employee in the Space Science and Engineering Center. That's the department we're housed in at the university. If you come to Madison, you see the big building, all the satellite dishes on top. That's where we're found. Much later, I got the chance after I was finishing my PhD to work at the university full-time in Antarctic work and be a faculty member at Madison College. The work we do is funded by a variety of projects, but it's primarily the National Science Foundation. The National Science Foundation funds and oversees the U.S. Antarctic program, and that's been in order since the era of Eisenhower through Ronald Reagan, through Joe Biden. They've all ordered the NSF to oversee the Antarctic program. We do a little work with NOAA, National Oceanic and Atmospheric Administration, a little bit, and we work in particular a little bit with the part of the U.S. military that supports the Antarctic program. For weather in particular. Currently, it's the Naval Information Warfare Center out of Charleston, South Carolina. I get the chance to be a part of some organizations. So Lee and I are members of the the International Commission on Polar Meteorology. So we get to help put on science conferences, get our science out to the world. And I'm also, yes, a member of the Scientific Committee on Antarctic Research. So when the world got their hands on Antarctica and set it aside for science, part of the folks who really oversee it, besides national management, is scientists. This group called SCAR. We're the group that do that part of that work. Lee, please introduce yourself.
So I'm Lee Welhouse. I am, as mentioned, I was born in Manitowoc and grew up in Two Rivers. So I went to UW and really had a great interest in weather. Did my undergraduate degree there, and then applied for funding, originally expecting to work in some sort of modeling effort. Ended up getting funding working with the Antarctic Meteorological Research and Data Center, and they said, you might go to Antarctica once in your time. And 13 trips later, that was definitely true. I might go once. I did my master's degree with UW. And then I'm now an instrumentation engineer. So the majority of my life is building, maintaining, designing, and studying the best ways to observe the weather.
Bring that penguin back.
Yeah. And this is Teddy. He's helping out with the talk.
Absolutely. All right, we should have a little geography. Tell you where we are in Antarctica. So here's the Antarctic continent. And by the way, you'll notice there's a lot of sea ice that extends out. In wintertime, Antarctica grows almost twice as big as the actual continent, although a little less the last year or two. So to give you a sense of where we are, by the way, on the big lobe that's on the right side of the screen for you, that's East Antarctica. The smaller lobe is West Antarctica. And there's a mountain chain that kind of divides the continent roughly into 1/3, 2/3 parts. Part of this talk that we're going to be talking about is centered here. Ross Island area, the Ross Ice Shelf area of Antarctica. A lot of the pictures we're going to show this evening are from this portion of the continent. This is where the main U.S. station is located. It's actually right next to the New Zealand main station as well. And so we'll be showing you a lot from this area here. It is a pretty place. And we'll talk more about the penguins later. One of the things we're famous for doing, and it's one of the first projects I got to work on when I was working for my predecessor, Dr. Stearns, who ran this project for over 27 years, is to take all of the world's weather satellites and put them together like a jigsaw puzzle over the Antarctic. And here you can watch the storms orbiting, really just rotating around the continent. We don't have the luxury of looking at the southern hemisphere, especially in the polar regions like you do here in Wisconsin or the United States, where you have rapid imagery Satellites always staring at it. Here we don't have that. So we actually take everybody's satellites and make this here. We're one of the few groups in the world that do this using both geostationary and polar orbital satellites. So which why we're uniquely positioned to be able to do that work. And I had fun making this picture, by the way. The Antarctic is just off to the right. You can barely see it. This storm is all out in the ocean. Isn't it just something? It's huge. It's just massive. I don't know if anyone can see it. Probably not. There's a little iceberg here, right about here. Does everyone see that? Yeah, that iceberg, by the way, is the size of Milwaukee, out to Madison, out to Dubuque. It's huge. It's that long. I'm serious. It's that much driving it would take you to go across that space. So that just gives you a sense of the scale here that we're talking about. It is quite tremendous. All right, why a weather station? Why should we do this? What do you think? Oh, I know. This is one of the biggest data voids in the world, where we just don't have measurements. So here on the map, you see some yellow dots. Those are the only staffed stations. And I think we've added like 1, 2 maybe along the way since this was made, but that's about it. It's not very many. So we want to be able to capture the climate of this big anti-area somehow, capture the weather of this big area somehow. And so using a station that can run, we got anyone who wants to go? Anyone? You want to take weather for me every 10 minutes all the time? Really?
No sleeping.
No sleeping. Yeah. See, I usually get when I ask children at grade school, they immediately all their hands come down when they realize they have to stay up and do it all the time. They're like, "Oh, I don't want to do that." It's a lot, right? It's a lot of effort. So this is why it's great that we have people there, and they still do staffed observing. People are out there making measurements, but it's great to have these, and that way we get the capturing a capability and something that's reliable and runs year round. And we're really fortunate to have that capability here. This is our 45th year last month of running weather stations in Antarctica. Originally, it was, and I had fun actually doing a little research on this because I didn't know much about our project before 1980. Then I looked around. Ever since the world decided to set Antarctica aside for research in the International Geophysical Year of 1957, then the race was on to figure out how can we get a weather station to run all the time. And they weren't very successful. And a lot of people tried. The Navy tried, and academics tried, and it just never had much success. Then some engineers figured it out, by the way. But they were engineers at Stanford, and they were like, okay, we're done with this. So then they wanted to figure out who would be the right person that could take this over. And my predecessor, Dr. Charles Stearns, was doing weather stations here in Wisconsin. So that really helped us have the ability to do them. By the way, someone mentioned atomic. Guess what powered these things initially? Radioisotope thermoelectric generator. Yeah, they were nuclear powered devices that ran them in the 1980s. Can you believe it? We got rid of them all. We don't do that anymore. It's all solar power and batteries, right?
Yes.
Yep.
Lots of heavy batteries.
Yep, absolutely. So these are the stations. Did you want to talk a little bit about them?
Sure. So naturally, that's going to happen. He's almost reached his limit. So this is a modern weather station. The original weather stations were temperature, pressure, wind speed, wind direction, transmitted out every 10 minutes. And we would, because of the style of transmission, it would retransmit every 3 minutes, give or take. And that's because you never knew when a satellite was going to be overhead. So you had to just spam it out as much as possible, trying to get that data out consistently. Now we have more data. We're still using that old style transmission, Argos satellites. So we still do that means of transmission, but now we can store more on board. We can do averaging. We can do a lot more with commercial off-the-shelf data loggers and data loggers we're trying to build ourselves.
How much memory y'all put on your phone? Yeah. Anyone know? How much you got? Yeah, 256 what? Gigabytes. The original weather stations were 256 kilobytes, just bytes. We moved up to 16 kilobytes, and that was a big improvement.
Yes, and we're transmitting out on the old style transmissions 32 bytes, and now we have a lot more instrumentation. So we get humidity, we get incoming solar sensors, we have multiple temperature levels, and we get snow accumulation. Yeah. And we're now transmitting it out this way, and also now with satellite, with Iridium satellite. which is something that allows us a
satellite
lot.
phone.
Yeah, satellite phone, which allows us a lot more throughput. We can now transmit out a whopping 360 bytes per transmission.
You know, it's small, but
But
does the job.
But we can get a lot done with that amount of data.
We really can. One of the joys of the job that I get to do, I've been really plugged into the rest of the Antarctic community internationally. The minute you do work in Antarctica, you're going to automatically be on the international stage. So we partner with everyone from all over the world. And one of the things I've enjoyed doing is keeping a map here of all of the automatic weather stations from every nation around the world. So here are all the different colors of all the different stations. And with this, it's a fair number of stations, 150-ish or so, 160-ish. It's varying a little bit over time. To give you a sense of the number of stations we're responsible here in Wisconsin, it's all of these in the triangles. So it's just shy of 57. We obviously don't do them all alone. We do a lot of the red ones ourselves, but we partner in the other colors with Japan, France, United Kingdom. So we have these partnerships that really enable us to make sure we have the opportunity to make this network be all that it should be. Should we talk records? We should probably talk a few records. Yeah. 2 records. Let's talk a few records. Now, a group of us we got tasked by the World Meteorological Organization to look into what is the highest temperatures we've ever had in Antarctica. So it was an interesting commission to be a part of, folks from all over the world. And if you count Antarctica as everything south of 60 south, which is that white circle around Antarctica, that defines the Antarctic region. The British at Sydney Research Station, it's on an island, has the highest temperature at about 67. Okay. And it's been like that. That's 1982, happened a while ago. That's the top. Yes, Fahrenheit. Amazing, isn't it? Not as warm as you might expect, but you're in the middle. I mean, that Sydney Island is really, it's on that banana belt of Antarctica, the peninsula. It sticks way up towards South America. So I call it a banana belt affectionately. It's kind of really a bit far north. So we as a community said, what about stations that are touching the continent? What's it like there for the highest temperature? That record was recently broken by Esperanza Station, an Argentine base, in 2015. It's 63.5 degrees Fahrenheit. Amazing, isn't it? That's pretty warm. Something you wouldn't expect. One of my colleagues, not me, I didn't do this, said, hey, a lot of Antarctica is tall. So when you take a look at it, notice there's this blue line that kind of encompasses most of the continent. You probably see this very vague blue line here, right? That's where the elevation of the continent is over 2.5 kilometers tall. Antarctica is one of the tallest continents in the world on average. So someone asked, what's the temperature, highest temperature in that space? And I didn't realize this was going to happen. It's one of ours. A station called D80. It's now since been moved. We moved it to a place called D85, which is about 50 kilometers away, that we partnered with France on for many years. And it occurred back in 1989. 19 degrees Fahrenheit. Wow. Isn't that something? Probably stuff you wouldn't think of for the temperatures. Do you want a reminder of the cold? Quick reminder. So there's the station. That's what it looked like. And that's where it's located. Cold, by the way, world record cold. Vostok Station, 128.6 that occurred in 1983. I'm really trying to break that record. It's tough to do in a warming world, but we're working on it. We'll keep you posted.
Trying to find a few spots.
Yeah, we believe they're there, but we don't have a station there. So stay tuned.
And it's difficult to get to.
They're tough to get to. Absolutely. This satellite composite imagery that we get the chance to put together shows an awful lot of the storms, as noted, going around. We normally do it just like the satellite imagery you see on like the TV weather, for example. We also get the chance to do this to actually highlight where a lot of the water vapor content is in the air. It's kind of really slick to be able to get the chance to do that. And I want to tell you a tale about something that took place a couple of years ago. And it's focused on this station here, or these couple of stations here in East Antarctica. So Dome C, when the Americans were there back in the 1980s, we called it Dome Charlie. It's now occupied by the French and Italians. They actually have a permanent station there. So there are people there right now, actually. They're all the time there now. And it's tall. That's one of our higher elevation stations. And so this spot here had some very interesting things developed not that long ago. So this is the entire temperature record for Dome C, Dome Concordia, as the French and Italians call it. And you see it's got lots of variations, but you can clearly see the winter where it's really cold, right? Remember, their summers are opposite ours, so we're having lovely summer here in July. It's their winter, right? And you can see the summertime in basically just January and December. That's pretty much it. But look at the red for the year 2022. All of a sudden, in this 1 year, we all of a sudden had this massive spike. Look at this. Now, March 18 of 2022, it's March. The sun is down in Antarctica. It's not the sun that made that really warm temperature. It's dark all the time, like now. And so how did it get that warm? And it lasted, by the way, for a few days. So this was a dramatic event. So we had the chance to study it with our series of weather stations that went from the coast all the way to the interior. So there's all of our stations there. And here we have their temperature plots on the side and our satellite view of it. Now, I love these satellite pictures because they're telling you about temperature. Everywhere it's bright white, it's cold. And of course, clouds are cold. And by the way, the Antarctic surface, when there's no clouds, it's cold. So it's very bright white. Watch what happens, though, as this event takes place. So I added arrows to show the clouds moving in over the continent. See how it becomes less white and becomes a lot more gray. Big, massive amount of air over the Indian Ocean moved in a very short amount of time and washed over the high East Antarctic plateau of Antarctica and created this big temperature rise. And it was tremendous. I mean, this is just something we haven't seen in our instrumented record to date. The temperature got to the record. We've never had a higher temperature there than this. It was 15 degrees Fahrenheit. That's the highest we've ever recorded at that location. That is 6 standard deviations above the normal. That's tremendous. You just never get that. The other stations were also high. 4 standard deviations. Here's 3.7 is another 4.7. Just unbelievably very, very different from the normal. So we eventually published this work with, I think, 52 of our favorite friends across the world in 2 parts. It was a lot of effort, but we were really excited to tell everyone about it because it's just an amazing event. All right, is this the part of the thing where everyone can take out your phones? My students love to do that. Like, oh, we can take out our phones. One of the things we've been doing for a long time in our group is we've been an archive of meteorological data. Our predecessor, Dr. Stearns, would come on our office and he'd hand us a diskette. Here, put this data online. Okay. We love to give data away for free. The Antarctic is one of the things I enjoy there. There's a treaty, and the treaty that we're a part of, data exchange is a part of it. We're supposed to do that. In fact, we're required to do that. So we've now did it from a kind of an informal thing. We're not formal. We're the United States actual data repository. So we're the library for U.S. Antarctic meteorological data. We got about 5,000 data sets. I think 4,000 of them are the weather station records. We got another 1,000 of our own or other people's links to people that are elsewhere in the world. So if we don't have it, we can tell you who does. So we're really excited about this new project. We're kind of a little late to this game, but we're excited that we're here. All right. What do we need for the trip?
Yeah.
What do we need for the trip? Go ahead. What do you want?
I was going to say, we obviously, one of the big things that if you ever see pictures of people in Antarctica is the coat. And
yeah, do we have what do you think we need? What's your thinking of what we need? Boots? Yeah, okay, fair enough. Other thoughts? What other things do you think I need for the trip? What's that?
Beer, yeah. Entirely true.
Wow, you've actually read a few average scientists. Well done. Yeah, other thoughts? What else do we need to bring? Yeah. What's that? Goggles.
Absolutely.
Okay. Absolutely, yeah. Other thoughts? Anything else? Yes. What's that?
Helicopter.
That helps.
Transportation is always good. I couldn't bring a helicopter. Do we have a volunteer? Do we have anyone who's a volunteer? Anyone who's feeling cold? Want to come on up? Come on up. Come on up. Yeah. We get issued 35 to 75 pounds of extreme cold weather gear, depending on what your job is and what you do. So this is my sample. There you go. And yes, we start out with Big Red.
We're very inventive when we name things. It's Big Red.
Yeah, you gotta love that.
Because it's red.
How's that feel? Yeah, okay, pretty solid. All right. And yes, you do need a solid boot. I won't make you put the boots on. So,
Bunny boots.
yeah, the classic Navy bunny boot that we've had in the program forever. I'll pass this one around. By the way, keep in mind, it has a little valve on the side. The valve, actually, oh yeah, can I do that? Sorry, I've been to like the wrong place for this. There we go. So the valve, who's ever flown and has their feet get all swollen up? Does anyone have that problem? Or is it just me? Okay, a few, right? Because this is what? This is basically encasing your feet in rubber. This allows airflow to go in and out, so it doesn't do that to you, right? But when we get to Antarctica, you want it closed up, so no ice and snow get in it and make your feet cold, right? So this is pretty chilly. I've had it in my car, but you're welcome to pass it around. I won't make you wear that.
Very.
Yeah, it really will.
It's oftentimes too warm.
Yeah, right. Because we wear alternative boots at times. You don't like them, but I like it.
Yeah, I'm not a big fan of those. They don't give enough support. Because a lot of our work is climbing towers. So those aren't the best for climbing towers. They don't give you the support for doing that.
Yeah. So here's, like I said, all the gear we're going to show you is hanging. This is at the Clothing Distribution Center in Christchurch, New Zealand. That's where we begin our travel. So we take commercial flight to Christchurch, New Zealand, and then from here we begin our travel down. So you got gloves at home?
Yeah, I do.
Liners? To go with the glove? Okay, great. Then you put these on.
If you're really cold and you're taking a long
By the way, how's the
traverse.
jacket doing for you? Warming up?
Yeah, warming right
Not
up.
bad considering that it was pretty chilly, right, when you first put it on, and now it's warmed up. Yeah, really good. Now, I won't make you put on the rest, but we always wear layers. This is a layering system, and it's purposely done that way. So if you get too hot, you can take off a layer. So I have synthetic polar fleeces underneath, and that kind of thing. One time I said, I'm going to shortchange it. I'm not going to put on the polar fleeces, and I'll just put on my wind pants and go out. And I was wearing jeans underneath. You giggle. Right? What are jeans made of? Cotton. Cotton does what? It freezes.
It gets stiff.
Yeah, because it's not only trapping heat, but also moisture. Oh, yeah, I learned that the hard way. Don't do that. Right, so I'll literally wear synthetic layers, and so it wicks the moisture away, but keeps heat in. Right, so it's a layered system.
And again, I wear jeans all the time when I'm down.
I know you do, but I can't, and it isn't, because if you get wet, the wet evaporates.
Yeah.
And then if the wet evaporates, you're at risk for frostbite. Not a good. Thank you very much. Let's give her a hand. If folks want to come up, I've got goggles in here someplace. And
goggles in particular are very important
in
Antarctica because you're getting a lot of snow, sunlight reflected off the snow. You can get what's called snow blindness if you don't have a good pair of sunglasses or goggles. I mean, I'm sure if you've ever been out skiing around here, when the sun is out, I know it doesn't happen all the time, but if it happens, you can get really bad, just like sunburn on your eyes, which is no fun.
Snow blindness is a real thing because you're getting sun reflection right off the snow. It's an issue. Sunscreen. Did people know you needed to bring sunscreen to Antarctica? Yep. Yeah. Just like when you go skiing, it's not only coming down at you, which that's right. We're missing something in Antarctica. What's missing? What's that? Yeah, there's not enough. Right. We always talk about it being a hole. It's really a dramatic thinning. There's not a lot of it there, right? So therefore, you get a lot more ultraviolet light, and you not only get it coming down at you, but reflected up. And so you burn in places you don't expect, like here, or here, or here. Yeah, you got to put it on. Otherwise, it's not a good time. Absolutely, it's a real issue. So once you arrive in Antarctica, here is me arriving. We fly in with either the 109th Air Guard out of New York. They're the last military unit that fly with skis. Also, we do fly in with C-17s. The U.S. Air Force takes us down. We go. It's the 139th Expeditionary Force is what does all this work for us. But we do partner with New Zealand. I've flown with them, with the Royal New Zealand Air Force. You flew with the Italians this year, didn't you, or no?
No, but I have flown with them in the past.
Yeah,
I've flown a commercial airline off of.
Yeah, we've done that too.
As well as a commercial one out of the deep field when we needed to be medevac as a group.
Right on. So this is when you turn around. This is the island. Oops. What's here? Volcano. Did anyone know? This is the southernmost active volcano in the world. And please note, it's not like Hawaii with the big pool of lava. It's just doing this.
I mean, it does have a pool of lava.
Yeah, but it's not like this big melty thing that's coming down the sides. It doesn't really do that. But it does do this an awful lot. So this is what there's, and it is actively studied. It's one of the most, it's studied because it's being this most southern active volcano. This is McMurdo Station. This is the U.S.'s main station, of one of 3 in Antarctica. It is the largest station on the continent among any country. It holds, well, I've seen it hold 1,300 people, which is way too many.
Yes.
Today, we're doing a little more like, what,
800
6
to
or 7?
900.
Yes, yeah, okay.
So there are different times of year. Actually, right now, they are finishing up vessel operations. So the main way they get resupplied is a large boat comes down.
Yep.
And
yeah.
And this year, actually, there were 2 because they're doing a major, thanks, bud, major rebuild. Yeah.
Yep. Yeah, they're going to work on redoing the station. Some of the buildings you see here are still vintage 1956 when the station was first built.
Yeah.
A lot have been replaced, but they're going to all modernize it. So we're very excited about that. It'll take a while, but we're excited it's going to happen. So.
And population ramps up. During the year, this year, it was around 650 to 750.
Yeah, not bad. Does anyone know what's in the big round things? Water, sewage. I love this. Oil. Yeah, it's fuel. I get these other answers. By the way, they actually treat the sewage there on site, which is lovely. But yeah, unfortunately, we do that. Now, as a note, I don't have the picture with me, but behind me, there's now wind turbines. They completely power the Scott Base station, and the extra power goes to the American station. When there's not enough wind, then the Americans power the Scott Base, the New Zealand station. So,
and I believe the plan is over the next 5 years to replace those because they are starting to. Yeah,
they're starting to go. But
and the increased power will generate even more power.
Even more, yeah. So there's the new rebuilt of McMurdo Station will have more and more and more renewables, which is really good. So we won't need to rely on this stuff so much in the future. We use every mode of transport possible to get to our other stations. You name it, we've done it. So getting to Antarctica, helicopters, twin otter aircraft. Yes, we've taken Coast Guard vessels. My predecessors did. I didn't get the chance to do that. Tracked vehicles, vans, buses. We have a fellow in the group who took a hovercraft once. Didn't work so great, but they did it anyways. I like this one. We're retiring Ivan, the Terrabus. This has been a famed vehicle. Those tires are as tall as I am. It's a big thing. So yeah, this was transport from the airfield to the main station. The airfield is actually a ways out from the station. Don't I look happy? I was not happy. We had driven out in these tracked vehicles, and notice how deep the snow is. It was up to my hips. We didn't have enough gas to get to the weather station because it was too fluffy. It was really disappointing. It was like, we can't get there. We had a snowmobile the next day. So we, like I said, use every mode possible.
And soon we'll be doing polar trucks.
Yeah, we're going to do a truck. That's the next thing. On the plateau. We're dying to try that out. So here is ship resupply. This is the southernmost place in the world you can sail a ship. So here, Winter Quarters Bay. And by the way, if you look off in the distance here a little bit, you'll see there's a building here in this little peninsula. That is Sir Robert Falcon Scott's hut. It's still there. By the way, everything he left behind there is still there. So you don't throw things away. What do we got here for like trash, recycling? That's about it, right? Not in Antarctica. In fact, you have to go to like garbage school, as we affectionately call it.
Yes.
You have to learn to separate everything at source. So, here's where the paper goes and green glass, and this is where metal is. And it's all separated at source. The Antarctic program, I think, recycles over 70% of everything in the waste stream. What are we in the States? 20? 25. It's not as good, I think, and so maybe it's improved, but it's not the same rate here, so it's a big deal. What are we doing there? You want to tell us?
Sure. So this is actually me and one of our colleagues who has since gone on to another group in Colorado, building a weather station. This is at Sipel Dome, affectionately called Sipel Doom, because it's gets fog a whole lot, so it's very difficult to get into. The riggers came before us to put up the tower. Normally, we would put this up in a single day, but then it's a little more frozen in. And we climb, and we just put on all the equipment. So that when I say a big part of my job while I'm south is climbing towers, it's basically doing this or adding tower sections because everything slowly gets buried as snow accumulates. That's what it's there for. Snow is just piling up and piling up and piling up. And our options are either dig the entire thing out, which we don't generally have the time for. So instead, what we do is we add tower sections, 7 feet at a time, 10 feet at a time, or 5 feet at a time, depending on the location, the amount of accumulation it's getting, and what we can fit on the particular aircraft. helicopters generally don't have as much space, whereas the small twin-engine aircraft can take a 10-foot section.
Yeah. Cool. Excellent. It's a harsh continent. Not all the time do we find the stations in good working order. So here you can see it's not going to work for us because it's encased in ice. So liquid, super cooled liquid water in the clouds or fog, as it's moving in the wind, hits the tower and freezes on contact. And it creates this over time so that none of the instrumentation works. Or as you can see here in the upper right corner, it encases the temperature sensors in ice. So that's not giving us the air temperature anymore. We're getting the temperature of the ice. It's not very helpful. So we clean them up and they look like the station on the bottom, which is kind of a lot better. This is one of my favorite. The top of the station blew off. And to give you an idea of the forceness, it backed off the bolts, lifted the top, which is, by the way, an I-beam, an aluminum I-beam, and it threw it across this room.
Yeah.
All the way to the other end.
Breaking the cable that was attaching it.
Yep.
At the same time.
And the instruments, by the way, were still good.
Yeah. Still work.
Still work, which is great because these high wind sensors, they're a pretty special thing. It was made in the States by a gentleman that we're really glad to have worked with when he was around, and they're really helpful. But yeah.
And since then, we've actually had a similar system that another group was able to get out to. We weren't. They took pictures of it and we're like, well, it fell off. And we're like, oh, that happens before. It didn't fall off because it backed off. It fell off because it actually broke the tower.
Yeah. Isn't that amazing?
One leg of the tower was completely broken off.
Yeah. Also a little melty. On the right, you'll see a station that's tilted. We get a few spots that are getting a little melty, and so then the towers tip over because there's nothing holding them in the ice anymore. So we then remove those. So this one has been removed. Pegasus is no longer there. Now, I'd like to give you a little video clip. This is taken from the backseat of a helicopter as we're leaving a weather station site to give you a sense of scale of what the environment looks like around it on a nice day. We've just finished our visit there, and to give you an idea of how small these things are compared to the environment. So the helicopter will take off. It'll actually back up, and then between the pilots, you'll see the station. So I'm in the back seat. There are the pilots here. And then as we get around, I'll get a shot of it as we're flying past it. So what's that? Yeah, do you think? Yeah,
that's where a lot of them
the helicopters are all over the place. They come from, but they're to give you a sense of scale. And they're not easy to find when you're up at altitude. We're like looking for these little things. They're kind of a challenge to capture. So there you go. There's a kind of a view around them of what they look like. So if you were ever to be there, go there. That's what we see.
And trying to spot that from a mile away.
Yeah.
In not great visibility conditions is not always the easiest.
It's a challenge. It really is a challenge. Okay, some scenes from the field. Anyone want to gander what this is? Skua, yeah, which looks like what? Seagull, yeah, right on. So you got to be careful with your food when you leave the galley because they'll come after it. they like your lunch or whatever. What do we got here? Seal, yeah. So we got a couple of flavors of seals that are pretty friendly. The crab eaters, the Weddells. However, leopard seals, you don't really want to dress in black and white because then you look like a penguin. And they like penguins for lunch. That's happened. They've come up and had a bite and go, "Oh, you're a knee. That's not a penguin," and that's a problem. We don't work on the sea ice, so that's a good thing. So I didn't get to take this picture. It's from a diver they do diving operations in the Antarctic. This is the edge of the McMurdo ice shelf, actually, which is near the Ross ice shelf, near McMurdo. Now, what do you immediately see that has color? Yeah, the sea urchins. Yeah. What's the next thing that you see that maybe sort of has color? Starfish. Yeah. How about all those other solid things running around on the bottom? Yeah, bivalves. Yeah, look at them all. And I mean, even the dark stains you see on the ice itself, algae. Look at how much wildlife there is this close to the ice edge. And then, by the way, it's extremely cold water. So think like 30, 31 Fahrenheit. The fish, which I don't have in this picture, they actually produce an antifreeze so that speckles of ice, when it touches them, doesn't freeze to them, which would be a problem here, right? If we had fish in this environment there, they wouldn't survive. We're here, they're meant for it. And because it's cold, nothing's moving fast, and things are old. They've been around a while, some of these creatures, as far as I know. It's not my area of expertise. We don't really do this.
Yeah,
But-
but I got to see a talk from one of the lead diver this year.
Oh, did you?
And even colder than 31. Sometimes it'll
Yeah.
be down to like 29, 28.
Yeah, I've seen pictures where they filmed the ice forming from underneath, and you can see the salt brine ejection because it looks different. Kind of has a wavy look, kind of like, when you go to the barbecue and you see the waves coming off. It's such heavy, dense water. The light that's coming through it shows that as the ice forms. It's amazing how cold it can get. And the divers I got to meet when I first went down, they had a cool life. Speaking of Hawaii, they spent half their life in Hawaii and half their life here diving for sponges. The sponges made chemicals that taste bad, so the fish wouldn't eat them. Chemicals turned out to be inspiration for chemotherapy drugs, so they could be simulated for that. I thought that was like, wow, well, that's a cool job.
And this year, their big thing was getting sea spiders.
Sea spiders.
Because they were finding sea spiders in specific areas that were doing certain gas venting.
Oh.
And they hadn't seen that before. It was a new behavior. A behavior they would have, they can't guarantee it was new, but they hadn't seen it happen before, and it was something you would notice, given how it was venting, the wildlife around. Yeah, they were doing
tremendous.
a lot of cool diving stuff this year.
Does anyone know why it's so blue? No, it's not the minerals, although that's a really interesting answer. I appreciate that. No, it's not reflecting the sky. Ice and snow absorb in the red part of the white light spectrum, and they transmit through the blue. So that's why it looks blue to us. Isn't that interesting? Yeah.
You can actually dig far enough down that you can create a blue effect as well.
Yeah, we can. I don't think I could come to talk if I didn't have pictures of penguins, right? I think you'd all be upset with me. So we have a couple of weather stations that are near penguin rookeries. Please don't be fooled. They're loud. They do smell, just so you know. These are Adelie penguins, very close. We've got a couple of sites that are near this. So many of them here, right? In these rookeries. So they're here building nests and competing for space.
Hallett?
This might be Cape Hallett, yeah.
I believe this is Cape Hallett, which is I want to say 800,000 breeding pairs.
Yeah, something like that. Yeah, it's a tremendous amount. It's just massive amount. Yeah, absolutely. Yeah, the United States used to have a station there back in the 1960s, and it's been since abandoned. So, yeah, it's pretty impressive. 2 years ago, we had our first all-female crew. Yeah, that's overdue. I should have done that a lot earlier. I'm really glad to have had the opportunity to do it. Taylor here in the group, I had her as a student at the college. She became an undergraduate student for me at the university, got her master's with me, and I'm ecstatic that she's now an employee with me. She's made a career of Antarctic, which is really great. So we're excited to have folks like that along for us to do these kinds of things. And this is this year's team.
Yeah.
Go ahead, tell us about the team.
This year's team was myself, Forbes in the orangish pink glasses. He is an engineer for the Madison Technical College.
Yep.
And then we also had two people assisting us that work with the University of Wisconsin, Carolyn and Tyler. They were in early season to help us work on our tall tower effort. So this year we were two different groups technically, though we were all working together. The major maintenance team, so we were working on weather stations with plans to go to West Antarctica, and then the tall tower install team. So due to issues, we were trying to install a tall tower in Deep Field. Because of logistical issues, we had to move it into McMurdo, and we were able to do so. So we installed our second 100-foot tower. This one about a mile off of, or a couple miles outside of McMurdo.
Yeah, 6 layers of measurement, 6
Yes.
levels. So we're really excited to have that. And this is when they were done having it all set up. You guys were pretty happy.
Yes.
By the way, isn't that cool? Check out the mat tracks on the truck. Do y'all want that around here for driving?
Yeah. You may think you want that. The problem with that is you can't drive more than 25 miles an hour. What it says is 25 miles an hour. Otherwise, it might burst into flames and explode. They're very finicky vehicles, but they are great for going through snow.
So anyways, you can get a close up here of the different levels of instruments that we have that allows us to capture behavior in the atmosphere. We're collaborating with a former Wisconsin graduate. He's now at the University of Colorado Boulder, who will be doing most of the science work. And we collaborate with him, which is quite good. So here they are working on some of the things this season, right? So which station was this on that you got to go? Do you remember?
This one was Amelia.
Yeah, right on. We were studying some of the pressure problems we had at the station and getting them fixed, which was quite good. So eventually, we should end this talk at some point. Right? I get to once in a while they let me launch a weather balloon in McMurdo, just like when I was a little kid. Right? Isn't that kind of cool? Yeah, it's kind of cool. It is a pretty place, as noted. These are lenticular clouds. Don't they look like upside down, like teacup saucers or UFOs? The air is being forced over that dormant volcano, Mount Discovery, at such a rate that the air is pushed up and makes these clouds. They look really smooth and laminar. The wind is really bad there. I wouldn't want to fly an airplane. It's nice and calm where I'm taking the picture. There, it's really windy. I don't want to be really turbulent, but it's a cool picture. All right. So eventually we have to go home. There we are, boarding on the C-17 and head back. And here's one of the spots that we're doing some side-by-side testing, some of our new equipment that we've built at Madison College, the old Wisconsin weather stations, and the Navy's got a system out there too, the weather forecast group. And of course, we want to thank all these people who support us. We don't get to do this, like I said, without a village. Do you have time for a couple more? I've got the usual social media bits now. Do you want a couple more bits? What do you think? Should we do a couple?
They're good pictures.
All right, we got to do a couple more slides. This is my best selfie ever. That's Dave McLeod, one of our other field team members behind me in the red. The gal behind me, Sean, I was thrilled. We love taking folks who only get to go to McMurdo and then never leave. They never get to really see the rest of Antarctica. So we asked folks on their day off, you want to come and help us dig snow?
And doing that is called a number of things. Morale trip.
Boondoggle. Yeah. But she just did laundry. That was her job. And she was ecstatic to come on out with us that day and dig snow and get to see more of scenic Antarctica. And we were thrilled to have her along. We get to meet some famous people occasionally. Does anyone know who this person might be? And don't feel bad if you don't know. It's okay. It's Sir Edmund Hillary. Yes. Sir Ed loved going to Antarctica. Now, what's he famous for? Mount Everest. Do anyone know what he's famous for after that? He's the first person to drive in a tractor-trailer train across Antarctica. He is a hero in New Zealand. He's on the $5 bill in New Zealand. In fact, when we went to this reception for him, they told us, don't bring any $5 bills from the sign. So we didn't do that. He was just a happy camper. This is, by the way, the year before he passed away. I flew out with him on the C-17 and they let him up into the cockpit. We did things in the C-17 I didn't think it could do. So I was impressed. Anyone know who this is? And that's okay. Once again, you may not know. This is even more esoteric, I think. There's me. Yeah, yes. Right on. That's me.
Good call.
A royal?
It is indeed someone who's royal. Well done. Oh. It is this Prince Albert of Monaco. They had just signed the Antarctic Treaty, and he was so ecstatic about that. He's like, I'm going to go. And he spent a month in Antarctica. He saw over 31 days, he saw 28 stations. When he got to ours, he was exhausted. But he does, let's talk weather and climate. He was so enthusiastic. And his people are like, come on, you need to go to bed. But he was such fun to meet him. All right, one more story. So my first deployment to Antarctica, I got it now. This is, first time for me on a military aircraft. We got halfway and then we turned around and it looked like a nice day. I'm like, what are we turning around for? And then the guy, of course, the plane is loud. You have to wear air protection. It's like sitting next to a lawnmower or a chainsaw for 9 hours. It's really, you can't even really talk to folks. And he nudged me and he told me to look out the porthole. There's not many of those in an LC-130. And we're looking down from the Hercules aircraft and you could see these massive waves in the ocean. We didn't have enough gas to get to Antarctica because of the headwinds. Well, like a windy day like today y'all have in here, right? So University of Wisconsin is famous for a couple of things. One, we built the first satellite technology. So when you see satellite imagery, that was for geostationary satellites. That was built at the University of Wisconsin. Professor Werner Sumi and Professor Bob Parent. Oh, Dr. Stern's worked for those guys. Yeah. The world is small. And the first thing that Dr. Stearns did when he had his imagery is, 1967. What was new in sports in 1967? Anyone know? Speaking of the Green Bay Packers. Anyone know? What's that? Instant replay. Yes. So Sumi, he was watching the Green Bay Packers go, hey, I can do that. I know where my satellite data is, right? Geographically, geolocation, and I know the time. And I know how much distance the clouds move. Oh, time and distance, I can compute velocity. These are wind measurements from satellite. And all the edges are from geostationary satellites. And Wisconsin became famous for this. And in the interior, this is Antarctica, and that's the Arctic. Where the polar orbiters overlap, we can do it there too. But you'll notice there's a gap. we were flying in that gap around Antarctica and there's no wind. So no one had ability to know, oh, it's going to be a windy day, don't fly, or take extra gas or offload some of your cargo and, so you can get there. So I said, can we try it? People thought I was insane, by the way. They're like, you're going to do what? And we got it to work. I was really excited. I didn't do the science. There are colleagues at the University of Wisconsin who do this for a career. I just had the idea. And I was ecstatic that I got them some money so they could try it out. And we got it to work. So all in the blue, we actually can do winds in that space. It took a little while to make it so that it was as good a wind as any other thing from these particular, we make special composites for that. But we're really, really excited that we're able to do it. And now we don't do the boomerang thing so much. That's what we call it when you fly like halfway and have to come back to Christchurch. You're like, 3 times we did that. So I was like,
occasionally it still happens.
It still happens on occasion, but a lot less than it used to. A lot less than it used to. Yeah, we've really improved our forecasting capabilities.
And it's much worse if you're in a C-17 and it happens, because you can fly in the C-17 down and circle McMurdo for a few hours, waiting to try to land.
Yeah.
And waiting for weather to improve, and then have to turn around and come back. So it turns into like a 16 to 18-hour day in an aircraft.
All right, so we've talked a whole lot. We should stop here. We thank you so kindly. We want to make sure you ask all your questions, and everybody gets a sticker. Yeah. These are the same stickers we put on our weather stations, and you can all have one too.
And I do want to say thank you for accepting Teddy being occasionally wanting to throw things.
Entertainment.
Yeah.
It's additional entertainment.
Yeah. Nothing wrong with that.
What kind of questions do you have?
Go for it.
Yes.
The weather station, how would you describe the reliability of them?
It depends on the equipment involved. Generally, the reliability is very good in most locations, but any moving part has a chance of failing at any given time. So the temperature sensors, incredibly reliable. We prioritize reliability of the sensors themselves, so they're not going to drift significantly. So we know they're going to be good. Pressure, similar. There's not a lot of moving parts, so we prioritize ones that are going to last. Our pressure sensors will last 30 plus years. The Windbirds,
but they're really good.
The Windbirds, they can break pretty rapidly, and the accumulation sensors can break because they're basically little speakers that are sending out a sound pulse to measure how long it takes to hit the ground and come back. Those can break in a few years and need to be changed. And the Windbirds need to be changed probably every 5 to 6 years, because after that point, the bearings are going to go out. You need to replace the bearings, so you need to just swap things out and repair them. That's the biggest point of maintenance. And by that point, you're getting there to raise them up anyway, because the accumulation will bury the station otherwise if you don't visit it, depending on the location, in 3 to 5 years.
Yeah. We did a student who ran uptime. How much is it up? It's over 80 to 90%.
Yeah.
Which I think is amazingly good for such a harsh environment. Yeah. Next question, yes. Yeah,
Okay.
One, sorry, one in the back and the one in the front. Yes, please.
Sorry if I missed it, but
How many nations?
how many nations are represented with these weather stations?
Oh.
And also, do they fund themselves?
Yeah.
And I see you're funded by foundations and grants, but where does the rest of your money come from?
We're exclusively funded by the National Science Foundation here in the United States. I'm a little leery. We've been leery about taking money necessarily from the overseas without approval. So let me go back to the map here. We can have a quick gander. You can get a sense of how many folks are here. So when you take a look at this, there's over, it's not quite shy of 24 other nations that have weather stations in Antarctica, ones that run by themselves. All those spots, there aren't people. I mean, some of them are really close to where people are, but yeah. We are partnering a lot with some allies, in particular Japan. The trade is often, we'll give you the hardware, they put it up, we share the data. We publish science papers together, do research together. We may do hardware exchanges in the future, we'll see. But yeah, for the most part, everything is National Science Foundation. We haven't overly worked with another government other than collaboratively. And that's generally how that's done. No money exchange. We've ruled about that. We prefer to do it that way. So question, yes.
May I take a photo of that?
Absolutely.
How long does it take to travel from Chicago to
24 hours to leave Madison, to hop into Christchurch, New Zealand, and you lose a day because you've gone past the date line. Then you get a day to get clothes, sometimes 3, depending on the weather.
Sometimes 42.
Yeah, and then you it's the flight down was 1 day to McMurdo Station. If you're going further on to like South Pole or field camp to work out of, then you'll wait till that opportunity arrives thereafter. Long travel, yeah. I can be on like 5 plane flights, in a couple day period. Yeah, absolutely.
The second question is, what is the coldest temperature you personally endured, and what was that like?
My coldest is minus 68 with a minus 86 wind chill at South Pole Station. I was glad to have all this on. I only had this much of me exposed, and it was a cool day because it was bright, sunny day. When I went outside, it looked like someone had taken a fistful of glitter and did this. And there was all this glitter coming down. You can get what's known as clear sky precipitation form. No cloud required. It goes from a gas, water vapor gas, directly to ice crystal. It's like a needle, and I could feel the needles hit my cheeks and mouth. It's kind of pretty. It's very glittery. It's kind of cool. And that's sometimes all the precipitation they ever get. It's a desert. Actually, yeah, they have sublimation off the surface, but this is literally, it's like deposition.
How long were you able to endure it?
Not long. I mean, we actually hiked around for a little while, and I did cover these up at some point because we were doing a site visit, in particular in the clean air sector where they collect all those carbon dioxide measurements and weather measurements are all in a special sector. So.
And I don't have that cold a temperature, but I did at our plateau stations at Henry and Nico. It was minus 50, wind chill down to only minus 55. I was out there for 8 hours hanging on a tower.
Yeah, he had it worse.
But I was fine. It was great. I was actually very warm.
Yeah, because it wasn't that windy.
And also because
usually when you get cold, it's not windy. It's the only way you can get that kind of cold is usually it's not that windy. Windy mixes up the air. Nice. When it mixes up the air, temperatures are usually. But it's fun. We could debate about minus 50 being better, but
Wow.
Other questions? Yes.
My name is William Lindbergh. I actually worked with Pacific Architects and served at the South Pole Station in 2016 as a rover.
Oh yeah.
So to your question, I saw negative 108 degrees.
Sure.
Did you join the 300 club?
I am a part of the 300 club.
Does everyone know what the 300 club is? So
you talk about that.
Okay. So it is, and it's not, and it's dangerous. I never said this. Can we turn off my no, because the other stuff isn't. It's dangerous to do.
Yeah.
They have a sauna at South Pole, and they turn it up to 200 degrees Fahrenheit. And you go from there into the minus 100 below to experience a 300-degree temperature change.
Oh my God.
But that's not the only part, is it? What's the other part?
You do this naked.
But,
And you run around the pole.
you're wearing boots. There it is. No frostbite. It's dangerous. It's really dangerous. But
Yeah.
There's medical staff
it's
with us the whole
it's
time.
dangerous. Yeah.
And the way you can get away with that is because it's only that cold if there's no wind. It has to.
Has to have no wind to get that. But really,
No kidding. I know
You
you're
get a
tired.
card, you get a patch, what do you get?
You're tired.
I have no experience. I said that to my wife as we we're kind of.
there you go.
Yeah, no, you're tired.
Yeah, I just want to say, I'm a member of Manitowoc now. I'm a citizen here, and
Great.
I moved here 8 years ago now, and
That's right.
just
That's my face.
my experience working for the United States Antarctic Research Program brought me here to Manitowoc.
Oh, that's fantastic.
And I love it.
Yep.
I got my patch here.
I noticed.
And I can show you.
Lunch is nothing for you.
I can show you my challenge coins and whatnot.
There you go.
Let's
Very nice.
catch up later.
That stuff I don't have. Well done. Excellent.
Kidding.
It's welcome to be now.
Kidding.
I don't have anything to say about it. There's nothing to do.
Okay. Other questions that folks have? Yes, please.
What temperature do you keep your house at?
In here in Wisconsin?
No, when,
in New York?
when you're living you live in a house, right?
Dormitory.
Barracks or a dormitory.
Dormitory. McMurdo.
Yeah.
And when you're out in the field, we're camping in tents.
Really?
Yeah, Arctic ovens. They're not bad. Actually, they stay kind of warm.
So
Like, what is it?
okay, buddy.
But yeah, otherwise it's no different than your own house.
So yeah, and so staying in the tents. Most of the time when we're camping, we're in West Antarctica. So solar noon is around 2 a.m.
Yeah.
So when you're sleeping, your tent gets pretty warm. If you're inside of it, you also heat it up. I've had people hang a candy bar across their tent, and by the end of the night, it will have melted and drooped because the inside of the tent's getting to 70 to 80 degrees
They're pretty nice. Yeah, they're pretty
on a sunny
day. Because
a sunny day.
all the time.
Yeah.
2 a.m. and 2 p.m. are pretty similar. Really, the sun's a little lower in the sky at 2 a.m. and it's a little higher at 2 p.m. Pretty much, but it's up all the time.
Unless you're in West Africa, it's the opposite.
Yeah, right on.
It's all about where solar noon is.
Yeah, absolutely. So, other questions anyone has? Yes. Oh, we're studying it now. Okay, so we know we've definitely got to 137 miles an hour. That's Category 2 hurricane. We think we've pierced that significantly, and we're studying it now. So I haven't verified it yet, but it might be
We're trying to confirm it.
tens more miles per hour, more, like much more, which is impressive, really. To get that. Antarctica is famous for fast winds called kaibatic winds, and we have some spots where we catch them. Or we've got a few that are geographically sticking out in a spot that we catch really fast. So yeah, we've got some really challenging.
Get that kid on a baseball team.
We gotta do that. Question, yes.
When you go down the trip, generally how long are you there? Or are you always there?
It is different. I've done one deployment for like 3 weeks, which is rare. I was doing some computer work, but you've done the longest, right?
So my average deployment is about 2.5 months. Thank you for pinching me. But the longest I did was 4 months. I did 2 4-month trips in a row, back to back, and that was a long 2 years.
It's a lot. Yeah, usually 7, 8 weeks, something like that. Typically, depends on literally what logistics we're assigned. If we got flights, we're going. If we don't have any flights, we're kind of we like to come back here. Yeah. Other questions? Yes, in the back.
Is Antarctica melting? Is it getting smaller like the Arctic?
So the sea ice I showed you around the last year or two, it has decreased dramatically in a couple of quadrants. The actual continent itself has a couple of basins that are also melting. The West Antarctic, in particular, the Thwaites Glacier Basin, so much so that the United States and United Kingdom have done a massive research project to understand how that works. So we're learning about that. Scientific papers are being published all the time as they keep finishing that project. So yes, some places a little less so because it's a lot of ice, but yeah, there's some places. Yes. Yes, question.
Storms and things that seem to circulate around the continent, is that due to the Earth's rotation primarily?
Yes, the circulation that goes around is the Coriolis force. That's the rotation of the planet that gives it that spin. It's also, by the way, the same westerlies that give us storms here. That's what you're seeing represented there, except they're very much over the ocean around the other continent. Not that they don't influence the continent itself, they do. That's something we're actually studying some of our colleagues at the moment. But yeah, that's exactly what that is. Well done. Yes, question.
The winds at a given speed, do they contain more energy because of the density of the air being cold?
So that's interesting. I think the kinetic energy that you get out of the speed may not be, I don't know if it would be so much tied to the temperature or not.
I mean, there's probably a small effect, but I don't think it's a large
that
one.
it's big. Yeah, I'm not sure that that's the case. I
Just
think
want to throw
that
everything.
usually, if you're thinking about it, colder air is fairly slow moving because it is dense, right? So like if the katabatic winds start in the upper plateau, like Dome, Concordia, Dome, Charlie I was talking about, that's where they begin. But the wind speeds are slow. 5 knots, 10 knots, not much. But it's not till it gets to the edge of the continent and it goes, oh, there's a cliff. So like a ball rolling down a hill, gravity helps, right? And there's pressure gradient differences, temperature differences that are big. From the interior of the continent to way out over the Southern Ocean, it's the same altitude. It drives the wind. It's a fun game for you. And then it gets that gravity acceleration. And then you get winds at 20 miles an hour. Welcome. Yes. Other questions? Yes.
So what is the ultimate goal of all this data?
So a lot of the automatic weather station data is being used for a variety of topics. Weather forecasting primarily. It's used by a weather forecaster directly. It's used by numerical weather prediction. So simulations of the future, which most weather forecasters use, right? It's guidance to see what's going on. It's used to understand weather processes. We don't understand everything about how weather works. We're still learning about it. We haven't had the time like we've had here in the mid-latitudes to understand all those processes. idea. How do the storms work around here? How does this wind work here? Why do we see this place being more stormy than another place? We're still answering a lot of those questions. And then now, I've got a 30+ year record. We're just beginning to go, oh, I wonder what the climate's like. And is it changing? That's the kinds of uses we have. And achieved by other fields. Biologists want to look at, the penguins. How's the temperature reacting to the penguin population? Glaciologists are interested about the ice and the ice quality, or the precipitation that we get. Well, we're having a hard time getting precipitation. The accumulation on the top of the ice sheet. These are the kinds of things that support other fields as well. Yeah, very welcome. Other questions? Yes.
I know the answer, but I'm going to ask so other people.
Sure.
The amount of drinking water, or how you get your drinking water when you're in the field, in the tents.
So, at McMurdo, it's reverse osmosis from the ocean.
Right.
But in the field, we're melting snow, right? So we're literally getting camp stove. We keep a corner around the tent, where our area that we keep clean to shovel clean snow, and we melt it.
Or at bigger deep field camps, they have a bigger process where they use specific shovels that are clean. They pull snow from specific areas. They use a specific attachment to the bulldozer, push it in, and then you fill specific 55-gallon trash buckets and pour it into the melting machine. And that is what you have for drinking water. For at those locations, oftentimes they'll have a shower or a wash mod set up, so you can do showers, so you can brush your teeth, so you can, it's how you get any kind of water that you're going to use as a person.
Yeah, very, very conservative. Very little. Navy shower, 2-minute shower. That's it.
Yep.
That's all you get. Rinse up, turn off the shower, slide it up, turn off the shower to rinse off, and that's it. That's all you get. Yes.
Microplastics and
Yes.
PFAS.
Yes.
Yes, probably so.
There are.
PFAS, there are.
They've absolutely found both of those things in the snow around McMurdo and in the deep field. And particularly in McMurdo, for years, they allowed you to use certain, I don't know if anyone remembers the various soaps and things that would have little plastic beads in them to help exfoliate. They banned those about 7-8 years ago.
Yeah, we didn't know any better. So unfortunately, yes. We get a little of everything in Antarctica that you get here, unfortunately. Yeah, we're all connected in that. Other questions? Yes.
And that, I guess along those lines, more of the anthropological, the kind of the culture, what it's like to be on the continent, and if there's a microeconomy happening. I mean, think about international people. So is it barter? What is? I guess the
on station. Probably a little. I mean, you've seen the culture a lot, even more than I have. But when I've been, yes, you do really have. We have a language. That kind of varies vocabulary. That, for example, we're beakers.
Yep.
We're scientists. They call us beakers.
So do you show up?
That's affectionately called. Yes.
Do you show up with things that are typically made in Wisconsin and bring along?
Oh, there's the mini Wisconsin party. The Minnesota and Wisconsin folks were one of the 4th largest populations in McMurdo compared to folks in Alaska and Colorado. We have a party this year. Quite nice.
They didn't have one this year. The person that hosts it has stopped deploying.
Yeah, it's okay. We have to import the cheese curds, so it's really hard to get cheese. So there's some culture to it, right? You have to live here, right? So the slice of everything here, there, absolutely. So, no doubt.
I'm gonna let him run around and see what happens. Let's see if he cooperates.
Couple more questions. Yeah, we'll get rolling.
We saw some animals there. Are there insects there?
No.
There are these very, very tiny roundworms that are found in the dry valleys. There's this valley system in Antarctica that has no snow in it. And they're studied by a group of biologists. And there's these little tiny rotifers. They're very tiny. You need microscope to see them. That kind of thing is around. But otherwise, not insects the way you think about it. There's some grasses on the Arctic Peninsula. There's some algal mats, even at altitude in some of the mountains, even quite far south, 82 south, which is amazing latitude to see that kind of thing. But otherwise, no. The penguins, the skuas, the seals, the whales, right? The penguins like to stay away from the orca. You can imagine. No polar bears. Does everyone know that? No polar bears. It's really good for the penguins. Right?
It's my favorite fact about Antarctica. The name, if you break down, I'm sure linguists would be really annoyed with me saying that, but it means Antarctic, no bears.
Yeah. Right. No bears.
Leopard seals, though.
Leopard seals are there. Yeah.
Lots of leopard seals.
Yeah, yes.
You mentioned something, I think, is there no nighttime, like dark sky?
Oh, there is for the other half of the year.
Oh, for the other half, it's all darkness.
Yes.
Like
Yeah.
You get 6 months of light, 6 months.
Okay.
Yeah, and there's a little bit of a transition really between the two. But yes,
Okay.
couple weeks, but yes, absolutely. So when we go, sun's up all the time.
Because we need that to fly.
We need that to fly. It's better weather in the summertime and all that. Yeah,
Which is our winter.
our winter. Yeah,
Okay,
right now.
right now.
Yes, right now.
This is not a question, but we have friends whose son-in-law was on the Polar Star, and he would go there every year to
Yep.
break ice. in
Yep. We still go.
Yeah, I saw them this year.
Yeah, they're down there. We get their weather observations. We archive their weather observations. We've got all that. You want it? We've got it. Yeah, it's lovely. We're thrilled to have them along. Let's tour the ship. It's a lovely ship. I hope we get to have more. I really do.
He just retired.
Yeah. Okay. Cool. Yes.
That's right.
Is the salinity of the water around Antarctica getting warm?
That I don't know. Not being an oceanographer or studying water, I'm not sure. I'd have to research that to see if the salinity's changed.
I mean, I would actually think probably, it depends on how much sea ice is melting each year.
Yeah.
The past couple of years with more sea ice melt, probably, I would think a little bit
It might be, but I don't know.
impacted.
Yeah, I'm not. It's a good question. That's why I'm not certain. We have to look into it. So sorry about that. Other questions? Is there one more? All right. Well, thank you all again very much. If you wanted to.
So thanks again to Dr. Matthew Lazzara and Lee Welhouse from Madison here, UW-Madison and Madison Area Technical College. Wonderful program, and I think we've all learned something about how appreciative the cold weather when we complain about it is. We're doing okay here, and it's only a few more months. But we have some wonderful programs coming up as well. Next month is our next Think and Drink on March 6th, and that is with Larry Longboard Williams. He's a Great Lakes surfer from Sheboygan. So he's talking about surfing this kind of weather because that's when the surf is up, as you can imagine. And also on March 13th, Shipwrecks and Charcuterie. So that's with yours truly. I'll talk about some of the maritime archaeology shipwreck sites I've mapped in my career in different parts of the Great Lakes and elsewhere globally. And then of course you'll get to dine on some delicious, delectable treats. You can see Kobe's birthday on the 22nd as well. So the boat is turning 82 years of age. So that's exciting. It will be a fun event that whole day, discounted admission. So thank you all for coming out tonight. And it's just wonderful that we can have such great scholarship and really great research happening right now in our state, and really to be proud of Wisconsin's role in a lot of this cutting edge research. So you guys are a big part of that. So thank you.
Thank you all very much.